Algae harvesting is the physical removal of individual algae cells from the water. Waterways can become very impacted with microalgae that can be potentially toxic, so this removes an intact algae cell from the water.
When the algae in the lagoon gets too concentrated, we refer to that as a harmful algal bloom because it blocks out sunlight to the bottom where the seagrasses need it to grow. Algae blooms can also be harmful in the lagoon. When the algae blooms die off, it can take the oxygen out of the water and that can cause fish kills.
Algae harvesting in our hydronucleation flotation system works by physically removing the algae from the water. We pump the water into our system at about 700 gallons per minute. On a 24-hour cycle, that's equal to 1 million gallons per day. Our unit is separated into 3 different chambers. In the first chamber, we add a water conditioning chemical commonly used in wastewater applications. That's a coagulant. In the second chamber, we add an organic polymer that helps clump that algae together in what we call flocks. And in the last chamber, we introduce microbubbles. And those microbubbles attach to the bottom of the flocks, float that algae to the surface, and we skim it off into a collection tank at the end. After that's skimmed off and collected, we simply dewater that algae and take it to a landfill.
The funding for this project came from a Florida Department of Environmental Protection Innovative Technology grant that was focused on combating harmful algal blooms. So we're targeting the areas that have higher algae concentration.
We come up with our operating locations based on a bunch of different data sets that we've collected. We have handheld algae testing equipment. We send off lab samples. We also have the folks from Brevard County doing reconnaissance. We use satellite imagery. We use drone photographs.
The algae harvesting is being done over a period of 5 weeks to test out this technology and see if it's a good fit to add to our tool belt in ways we can help the lagoon.
So we've conducted various research projects before in freshwater and proven that our technology is very effective at removing algae in freshwater. We are testing our technology here in the lagoon due to various salinity levels, oxygen levels, different weather conditions, just to get a better hold on, does this technology work in brackish waterways, salt waterways, hypersaline waterways. And so far we're finding interesting results. We've had very, very different oxygen levels in the water depending on where we are in the lagoon. We've had very different salinities, and we're finding that our technology is a viable option to clean up algae. We can get elevated algae levels in the lagoon due to excess nutrients in the water. The nutrients come from various sources such as fertilizer runoff, septic tank runoff, and essentially elevated levels of nitrogen and phosphorus. That's what the algae like to feed on.
While this is a tool that can be utilized to address algae blooms as they're happening, ultimately we need to reduce the pollution coming into the lagoon to prevent the algae blooms from happening in the first place. So the Save Our Indian River Lagoon program has over 380 different projects that are focused on reducing nitrogen and phosphorus pollution into the lagoon. When they're all done, they're going to reduce over 1.3 million pounds of nitrogen pollution and over 106,000 pounds of phosphorus pollution annually. Residents can also aid in speeding up the recovery of the lagoon by reducing their own personal pollution. They can do simple things like eliminating the use of fertilizer, making sure their grass clippings don't get into our streets and waterways. And they can go to lagoonloyal.com to find many other tips and tricks that they can do to reduce personal pollution in their own lives.